Welcome. This is Dr. or Professor Jason Finley, and this is the Introduction to Physical Geography. What I want to do with these few slides here is introduce some of the concepts of physical geography and also show you some examples of information that we're going to learn in this course. In fact, right here, we have a polar bear that's on a piece of ice. This represents global climate change and the melting ice that we see in the Arctic areas. In addition to geographic knowledge, I always think that my classes have life skills and career skills embedded in them. So we're going to look into critical thinking, analytical, and problem solving. Because this is a science course, we're going to get into scientific thinking, writing. You will be doing some writing and discussion boards and textbook reflection assignments. And you'll be working with others in discussion boards and learn more team working skills. This map shows drought, and drought is one concept that physical geography looks into. And back in August of 2016, we were at the peak of the worst drought, one of the worst droughts that we've had in California's history. Los Angeles County was in the darkest red, the most severe drought, which is actually called exceptional drought. This map shows this past January's drought, and it shows an improvement from August of 2016. We've had some rain this winter, and a couple of winters ago, we had a above average winter rainfall event. So now we're just in a moderate drought, but we're still in a drought. So let's hope that we continue to get rain this winter. Something else that we look into, severe storms. So severe storms, we will look into the geography of severe storms and the dynamics of severe storms later in this course. There was actually a deadly lightning strike a few years back on Venice Beach in July, and that's pretty unusual. As you may know, we don't get a lot of lightning here in California. If you take a look at this lightning fatalities map, Florida is sort of the bullseye area for lightning. 471 deaths between 1959 and 2013. Compare that to California, which only had 32 deaths. When it comes to weather, which is a big portion of this course, I always like to look at the most severe kinds of weather phenomena. And you might think tornadoes, hurricanes are the deadliest weather events out there, but technically heat is the #1 killer. And that's what this slide is showing you. The #1 fatalities around the world. Flooding is also a big weather fatality. In addition to weather-related phenomena, we are going to look at the solid Earth. And with the solid Earth comes earthquakes. And so this picture here in the upper left-hand corner is the result of the Northridge earthquake back in 1994. On its 20th anniversary, there was a small earthquake. So at the bottom, it shows a seismograph at 5:28 in the morning, which is pretty close to when it was, pretty close to the time of the Northridge earthquake 20 years later. In addition to earthquakes, we're going to look into volcanoes. So in this image is the Mauna Loa volcano in the Big Island of Hawaii. I also visited Mount Kilauea, which has been semi-continuously erupting since 1983. I also visited Iceland in the last couple of years, and Iceland is a very interesting country. It's an island filled with volcanoes, and it's actually being ripped apart by plate tectonics, a concept we'll talk about in chapters 13 and 14. Right here is a bridge that connects two different plates. We have the North American plate to the to the west, and the Eurasian plate to the east. So I'm at the boundary of two plates. This is another look at that plate boundary. And down below, we see one of the largest, most recent volcanic eruptions in Iceland. And it actually grounded airplane travel in Europe because particles from this eruption would have actually damaged airplane engines. This is a volcano that used to have a cone shape, but now has collapsed and created a lake. And we often call these calderas. And this actually, again, is in Iceland and was used as an amphitheater for Björk's concert back in the 1990s. Keeping with the concepts of physical geography, when I talked about the polar bear on that piece of ice, I was really looking into global climate change, focusing on the Arctic areas. As you could see, compared to about 40 years ago, this decade has a lot less ice, and we're seeing less and less ice as the years go by. Speaking of ice, when I flew back from Iceland to Los Angeles, I flew over Greenland, and this is during the summer, and you can see a lot of glaciers. Now the glaciers are melting, and the melting glaciers is really what will cause sea level to rise. So this map is showing you what Los Angeles would look like if all of the world's ice sheets would melt. And as you can tell, most of Los Angeles would be underwater. We would be okay in Woodland Hills, but the rest of LA and even Orange County would be underwater. And there's some fun names to certain areas that are underwater. This quote is one of my favorite quotes that talks about the Earth and geography. People live on the surface of the Earth in a physical environment that is extraordinarily complex, extremely diverse, yet ultimately fragile. So you might be wondering, what is geography? Well, geography is the spatial analysis of the distribution of Earth phenomena. And you might be thinking at first, I'm going to learn where countries are, the capitals of countries, where rivers and mountains are. Not in this course. This course focuses on the physical elements of the Earth. So once again, geography is the spatial analysis of the distribution of Earth phenomena. This course, physical geography, is the spatial distribution of the physical elements of the environment, which include the atmosphere, the hydrosphere, the lithosphere, and the biosphere. And geography doesn't necessarily have a unique knowledge base. What it does is it takes information and knowledge from other disciplines like meteorology, geology, history, and it looks for interconnections. So what makes geography cool is its method of studying, which again is the spatial analysis of Earth's phenomena.